Hello everyone, welcome. With the face of mathematics. So we'll be dealing with limits problems. So we'll start with solving limits of factorization type. Let's take a look at the limit as x approaches 1 of the cube root of x minus 1, all divided by the fifth root of x minus 1. So if you can check carefully at this limit, both the numerator and the denominator they cannot divide from each other, but they do contain a common factor. So how do we find a common factor? We're just going to multiply 3 by 5. So which means we can express a cube root as the 15th root and also a fifth root as the 15th root. So what do I mean about that? This is what I'm talking about. You can see that the 15th root of x to the power 5 is the same as the cube root of x. And also the 15th root of x to the power 3 is the same as the fifth root of x. Remember, we can write 1 as 1 to the power 5 since our first variable, which will be for a, is power 5. And similarly, we can write 1 in the denominator as 1 to the power 3. So in the numerator, I'm having the expression of form a to the power 5 minus b to the power 5. It is clear to you that the 15th root of x is your a and 1 is your b. Is the similar case in the denominator, but the power is different. It's 3 instead of 5. So as in the denominator, it's a cube minus b cube. But according to factorization theorem, what are these two equal to? Since you know that a to the power 5 minus b to the power 5 is the same as this expression when factorized, and also a cube minus b cube is the same as this expression when factorized. So we're going to apply the same for the numerator and denominator. But now you are going to note down that a is the 15th root of x and b is 1. For both the numerator and the denominator. So we just have to expand this expression, the numerator and denominator, just using what we know. Meaning our limit can be further extended to this form, whereby we know very much well that for the numerator, this is the result. If you just substitute from this expression, where you see a, you put the 15th root of x, and when you see b, you put 1, and this is the result for the numerator, and this is the result for the denominator. That's very much clear and straightforward. So moving on, if you can check, there is a common factor between the numerator and denominator, which is going to cancel out. Then I'll be left with something which is easy to simplify. So continue solving the limit. I'll be left with the 15th root of x to the power 4 plus the 15th root of x to the power 3 plus the 15th root of x squared plus the 5th root of x plus 1 in the numerator. And also in the denominator, I'm left with the 15th root of x squared plus the 15th root of x plus 1. So from here, I just substitute 1 where I see x. Since the nth root of 1 to the power m, it will always be 1, because 1 raised to the power any number is still 1. So meaning in the numerator, I'm going to have 1 adding to itself 5 times, and in the denominator 1 is adding to itself 3 times, and the solution to the limit is 5/3. Let's verify this. Remember, the cube root of x can be written as x to the power 1/3, and the fifth root of x can be written x to the power 1/5. And according to the rule we've discussed on the previous video, if we are having a limit of this type, what we can do to find the solution is easy. We just divide the powers. So it's 1 over 3 divided by 1 over 5, which is the same as 1 over 3 multiplied by 5. Indeed, the answer is verified, 5 over 3. That's how we do it. Let's look at another problem. Secondly, given this limit, the limit as x approaches 27, 27x divided by 9 minus x to the power 2 over 3. And if you can take a look very clear, you can see that there is a common factor between the numerator and denominator. What I see that common factor of 27 and 9 is 3. And also common factor of x and x to the power 2 over 3 is x to the power 1 over 3. How? Let's just extend this limit, but to write it in exponential form, putting the idea of a common factor, as I mentioned. This is what I'm talking about. 27 is 3 cubed, and x can be written as x to the power 1 over 3 to the power 3. So if I multiply the exponents, you see, I'll get back to x. And similarly, here, x to the power 2 over 3 is the same as x to the power 1 over 3 to the power 2. So if I multiply the 2, I'll get back here. And also, 9 is 3 squared. So if you can check my new expression, in the numerator, I'm having the difference of cubes, and in the denominator, I'm having the difference of squares. And how do I go about that? Meaning, I'm able to factorize the numerator and the denominator. Remember, a cube minus b cube, which is the difference of cubes, can be factorized into a minus b multiplied by a squared plus ab plus b squared. And also, the difference of squares, which is a squared minus b squared, can be factorized into a minus b multiplied by a plus b. So now, take a look at this. Take your 3 as if it was your a, and x to the power 1 over 3 as if it was your b. So it's a matter of substituting what happened here in the numerator for the difference of cubes and also for the difference of squares in the denominator. And I can see indeed that 3 minus x to the power 1 over 3 is my factor, which will cancel out. So I'll be left with this expression. And taking it from here, where I see x, I'll have to substitute 27. Then we can proceed simplifying by using exponential law. But first, write 27 as 3 to the power 3. So you'll get to the answer easily. By applying the law product of exponents, 3 is going to get rid of 3 here, and also here 3 is going to get rid of 3, and similar case in the denominator. So I'm left with 9 plus 3 times 3 plus 3 squared divided by 3 plus 3. And this is nothing but 9 plus 9 plus 9. 3 times, then divide by 3 plus 3. So proceeding on, I'm having 27 divided by 6, which is 9 over 2, and that's our limit answer to the problem that we're solving. Hopefully you get it. Just look at it slowly, try to digest it. There's nothing if only you understand. Can we focus now on the third problem? So this is our third and last on the limits of factorization type. So first thing first, you are required to evaluate this limit. The limit as x approaches negative pi over 4 of sine cube x plus cos cube x divided by half sine 2x plus cos squared x. So what you need to do first is to change the sine 2x using the double angle strategy, that is the same as 2 sine x cos x. So if I substitute that to this limit, I'm resulting with sine x cos x plus cos squared x in the denominator. Proceeding with the limit, I can still factor out cos x in the denominator. And looking at the numerator, I'm having sum of cubes, which is in the form a cube plus b cube, can be factorized as a plus b multiplied by a squared minus ab plus b squared. So if you can look at your numerator, you can treat sine x as your a and cos x as your b. So if you try to factorize this expression, applying the property that I gave you now here, you get sine x plus cos x multiplied by sine squared x minus sine x cos x plus cos squared x. And the denominator, you keep it the same as it was. And if you can check now, I'm having the common factor in both the numerator and the denominator, which is sine x plus cos x, which must cancel out. And I'm left with 1 minus sine x cos x divided by cos x. And the question is, where did sine squared x and cos squared x go? Why am I having 1 now instead of sine squared x plus cos squared x? Since you know from trig identity, there is a rule saying that cos squared x plus sine squared x, it's always equals to 1. So what I did, I just replaced cos squared x and sine squared x by 1. Proceeding further, simplifying this limit, I'll have to divide by cos x from 1 and also from sine x cos x. So I have, and as a result, you can see on my second term of this limit, cos x will cancel out cos x. I'm left with sine x. And what is 1 over cos x? Since 1 over cos x is the reciprocal of cos, which is sec x, so I result simplifying my limit from here to sec x minus sine x. And I'm done. It's a matter of direct substitution. Where I see x, I just put negative pi over 4. So I'm having sec of negative pi over 4, which is the same as 1 over cos of negative pi over 4. And you know that pi is 180 degrees, meaning negative pi over 4 is just negative 45 degrees. We just divide from 180 degrees by negative 4. That's how you find the negative 45 degrees. And if I recall, 45 degrees is a special angle, and the cos of a negative is a cos of a positive angle. So cos of negative 45 degrees is cos of 45 degrees, which is a special angle given by the root of 2 over 2. But what I'm looking for is the reciprocal of cos of 45 degrees, which is given by 2 over root 2. That's for sec of negative pi over 4. And the sine of negative 45 degrees is given by negative root 2 over 2. So I'm having root 2 plus the half of root 2, and my final answer for the limit is 3 over 2 root 2. And that's it for the limit of factorization type. You're welcome. Please keep on supporting by your likes, comment, and subscriptions, and God bless you. You have few exercises that you can deal on. Let me write them quickly, then you'll have to pause, then you do them and see how far you understand.